Hello and welcome to our next video on indefinite integrals and the net change theorem. So indefinite integrals. This is where the notation, the integral of f of x dx, is traditionally used for an antiderivative of f. Thus, the integral of f of x dx is equal to capital F of x, means that capital F prime of x is equal to lowercase f of x. So we can regard an indefinite integral as representing an entire family of functions. And so the most general antiderivative on a given interval is obtained by adding a constant to a particular antiderivative. And I have a table on the slide here showing these indefinite integrals. So the integral of c times f of x dx is c times the integral of f of x dx. The integral of k dx is equal to kx plus c. The integral of sine x dx is equal to the negative cosine of x plus c. The integral of the secant squared of x dx is equal to the tangent of x plus c. The integral of the secant of x times the tangent of x dx is equal to the secant of x plus c. The integral of the sum or difference, too, for that matter, involving these functions f of x and g of x is the integral of f of x plus or minus the integral of g of x. The integral of x to the nth power dx is equal to x to the n plus 1 divided by n plus 1 plus c, where n is not -1. The integral of cosine of x dx is equal to the sine of x plus c. The integral of the cosecant squared of x dx is equal to the negative cotangent of x plus c. And finally, the integral of the cosecant of x times the cotangent of x dx is equal to the negative cosecant of x plus c. So the convention of evaluating these indefinite integrals is that when a formula for a general indefinite integral is given, it is only valid on some certain interval. So here's an example of finding an indefinite integral. Finding the integral of the cosine of theta divided by sine squared of theta d theta. So we could break this apart to help us find the integral. This would be the integral of 1 over sine of theta times the cosine of theta divided by the sine of theta d theta. And one last simplifying before we actually solve this. 1 over the sine of theta is the cosine of theta. And cosine of theta divided by sine of theta is the cotangent of theta. So this is the integral of the cosine of theta times the cotangent of theta d theta. And this will be equal to the negative cosecant of theta plus c. For example number 2, we want to evaluate the integral between the bounds of 4 and 9 of 2t squared plus t squared times the square root of t minus 1, all divided by t squared dt. We can break that fraction into pieces and evaluate each part. So the integral between 4 and 9 of 2t squared divided by t squared just gives us 2, plus t squared times the square root of t divided by 2 just makes the square root of t. So this would be t to the 1/2 minus 1 divided by t squared just makes t to the -2 dt. So this makes 2t plus 2/3 times t to the 3/2 power plus t to the -1st, evaluated between those values of 4 and 9. So putting 9 in first is 2 times 9 plus 2/3 times 9 to the 3/2 power plus 9 to the negative first minus 2 times 4, and I'll put this into another bracket, 2 times 4 plus 2/3 times 4 to the 3/2 plus 4 to the negative first power. So evaluating this entire thing, we would get as a fractional amount 811 divided by 36. Or as a decimal, this is about 22.5278, this rounds to. Let me know if you have any questions or concerns and be on the lookout for part 2. Thank you.